Guys,
Can
good
you start
evening.
the screen? Yeah.
Yeah, good evening, everyone. Okay, welcome to all in this like basic training program of 5 days. Okay, and yeah, I think Ruby ma'am has already introduced me. I'm working as a freelancer. Like freelance programming consultant, along with as a corporate trainer, and along with this too, like I'm also working as like machine learning researcher. Okay, so I have published multiple research papers with some like senior faculty members of Amity University, JCRC University, Delhi University. Okay, so these are like my things which on which I am working right now, and as ma'am told, okay, so from last 6 months we are conducting this kind of a program based on machine learning, deep learning, and yeah, various different kind of programs from basic to advanced machine learning, then deep learning, along with that natural language processing. Now, in this program, we thought of conducting a basic session on a data science, because like in a machine learning domain, like mathematics is one of the very a most important thing, and we are not able to like cover those things because of time constant. So we just give this special sessions, just program this special session for you, and you don't need like any prerequisite. You don't need and because this is for a beginners, so you just need your I just need your focus, your determination for next 5 days, and yeah, we are able to cover a lot of things, a lot of mathematics from this background. Okay, so specifically we are going to talk about data science, statistics and probability, and along with the statistics and probability, like whatever the things which we are going to learn in a statistics and probability. So we are not just going to learn only the like the basic concepts which I think which we already learn in class, maybe in class 11th or 12th. We are going to I'm going to talk about their significance. Okay, so their significance in a real world scenario, their significance in a machine learning, their significance in terms of artificial intelligence. Okay, so that is what we are going to cover in this entire session, and at last I will give you some coding session also. So we are going to implement some basic things which we are doing in a paper. We can implement those things also along with the Python programming language. So even you don't, if you have a knowledge of a Python, or if you have a knowledge of any programming language, then it is it's a very good it's a kind of advantage for you. If you don't know, then nothing to worry. Uh, you only need like basic knowledge, so that I will give you, and then only I will code for you. So don't worry about that. And but the main thing which you need to focus is the mathematical part, the mathematical section, and try to understand the significance. And that is what like maybe after this 5 day session, if you want to like continue, so that is what you need to you need to remember throughout your learning, and then you can do a statistical analysis. Okay, so whatever the things which we are going to learn, based on this you can go for like 3 domain. Okay, so you can try to hunt for like 3 domain, or like 3 kind of jobs available for you. So first is a data science, another one is a data analyst, and third one is a business intelligence. Okay, so these are the 3 things, three area, or you can say a domain, in which you can make your progress, or you can go after learning this after this 5 day session. Okay, so like it's up to you in which domain you are more comfortable. Okay, so fine, guys, and I think you already have a curriculum along with you, that what exactly we are going to cover. So we are going to cover like statistics and probability of two different categories of statistics, then a probability, then a probability distribution, then a parameters. Okay, so that parameter is nothing but a hypothesis testing kind of a thing. And along with that, we are going to cover, I'm going to talk about that how you can implement some basic things, some very basic things with a Python. Okay, so in a Python also I will give you a basic introduction that what are the data types in Python, and then there are like two libraries for a scientific computation. Scientific computation means through which you can perform any kind of a mathematics, any advanced level of mathematics you can perform in just 2 or 3 lines of a code, and that those libraries are nothing but NumPy and SciPy. So those libraries those are the libraries I introduce those libraries also. So yeah, this is just like a beginning for you, and you only need to focus for next 5 days. Okay, and this is my like a request to all of you guys that be with your notebook and pen. Okay, because we are doing to we are going to do a lot of mathematics, so it may possible, so along with the calculator also, so you need to do like some calculation. And if you are interactive, okay, so if you are interactive, if you take participate in that like calculation and all those things, then these sessions will be a more interactive for you. It will be kind of a fun for you. Okay, so it's my like humble request that be with your notebook and pen. Yeah, I know just why screen is there, because I didn't write anything over here, so that's why you are able to see only white screen. Now you are able to see statistics. So we are going to learn a lot of different things. But before starting, okay, so before going on to the statistics part, before going on to the statistics, the category of statistics, the main thing which you need to do. Okay, so 1 second. Okay, so let's start, and then just make your environment also, guys. Okay, so guys, any one of you can give me a basic introduction, any idea about like statistics? Anyone know about what is statistics? Just give me your like a definition. Graphical representation of a data. Graph. No, it's not a probability, man. It's not a probability. Probability is like having its own definition that we will run. Graphical representation of data. Yeah, Sumit Panchal is it's like not a exact answer, but yeah, it's correct. Okay, up to some extent. Analyzing data, you can use statistics for analyzing your data. Data for a couple of period, collection of data. Yeah, this is one of the like key point in of statistics, that you need to collect the data. It is better to be roughly correct than correctly completely wrong. That summarizes the stats. Oh, interesting one. Okay, so yeah, like good. I think everyone show their involvement, so it is like a very good thing. Okay, so I think in every definition, whatever the definition or whatever the statement you guys given to me, in every definition, the one word is common. Okay, so where there is. Okay, so one word, I think one word is very common in all the definition, and even the definition which I am going to write here also, that one word is going to be common. Okay, so statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusion from data. Okay, so so this is like a definition for a statistics. Even many of your definitions are also correct, and even I am very it's like very good thing, because this is I think this is my fourth or fifth batch with PPDC, maybe fifth one, and this was for the very first time I got I am maybe 6 or 7 responses for like one question. So yeah, it's good. Great, guys. So statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusion from data. Okay, so I think one of you written that it's like we are trying to collect the data. Yeah, even we are trying to collect the data, and we collect the data to do some kind of like I think one person has written that graphical representation. Okay, so not only the graphical representation you can say. So you try to you even try to organize the data, summarize, you try to make your own analysis, and a conclusion means you try to make a prediction analysis based on a data you are having. Okay, so this is what like statistics is. Even if I try to give you a more like a complicated definition, which is which is coming from a machine learning background. So you can even write that statistics, so it is a science of uncertainty and technology of extracting information from data. Okay, so uncertainty, it's like I think one person has written also in I think the same thing in different language. But yeah, it's a science of uncertainty, and we are trying to extract lot and lot of information from the data. Okay, so that is what a complete definition, that is what a definition of a statistics. Okay, now guys, I think if you have noticed, so one word is common in like whatever the definition, whatever the statement you have written, and whatever the definition I have given to you, one word is common, and that particular word is what? Data. Okay, so let me first know that every one of you are like able to understand like this definition, or what definition I have given to you, like statistics, science of uncertainty. Yeah, no one is having a doubt with that definition. Okay, fine. Now, so this word is like a common in all the definition, and yeah, but this is this word is like very important to make even this definition, and even whatever the things which we are going to do, even if you are trying to do like a machine learning or whatever you are trying to do, so this word is very important, this term is very important. Now, what is data? Okay, anyone? I think this is a very simplest definition. Anyone can give me can define a data for me? Okay, so it is nothing but I think a piece of information that can be measured. Okay, just a single line definition. Even you can have your own collection of information. Yeah, very correct. Collection of information. So I think I have I said the same thing, that a piece of information that can be measured. It is called that is called a data. Okay. Now, okay. So before going going into the detail of category of a statistics. Okay, so before going into the detail of a category of a statistics. Yeah. So category of a statistics, that is a descriptive and inferential. So before going into that, I think we first need to know that what are like different kinds of a data are available. Okay, or even this is also called, you can also call it as a like a variable or a random variable. Okay, so what are like different kinds of a variable, or what are different kinds of a random variables? Okay, so anyone like can define a variable for me? Or what are the different kinds of a variable? Yeah, definitely. So there are two like different kinds of a variables. One is a quantitative variable. So quantitative variable, and another one is a qualitative variable. Okay, now even this quantitative, yeah, quantitative and qualitative. Now like what is this quantitative variable? So so what is this like quantitative? So even this quantitative variable can be divided into like two categories. So even this can be divided into like two categories. One is a discrete, another one is a continuous. Okay, now this is guys, this is main part. Okay, so what is what? Okay, so what is the difference between discrete and a continuous? Okay, just give the example and just short it out. Okay, so what is the example you can give for the discrete, and what is the example you can give for the continuous? For discrete, continuous is temperature. Uh, this is even confusing, Bikram. For discrete, continuous is temperature. What does this mean? Continuous can be for the breakable. Okay, continuous age of people, 10, 20, 20, 30. Okay, continuous variable example is temperature. Okay. Discrete variable is population. You are mixing something, okay, which varies time to time. It is discrete or random? Sorry, discrete or continuous? I need to ask. Okay, so discrete variable means like uh, I think the integer values. Okay, so you, I think random variable can be anything. That is completely possible. That is completely fine. I think random variable we already discussed. Now we are discussing the types of random variable. Okay, that is quantitative and qualitative. And even in quantitative and qualitative, we are trying to discuss this quantitative, which can be further divided into two categories. One is discrete, another one is continuous. Okay, so I think now I'm asking you that what is a discrete random variable and what is a continuous random variable? Okay, or just a differentiate between a discrete and continuous random variable with the example, or just by the definition. That is what I think I'm asking right now. Okay, okay. Okay. So a discrete variable is your whole number, or you can say a integer numbers, Okay, so like in between like two numbers, there is there is no number, or there is no there is no number in between two numbers. Okay, so in between if I can say like in between 2 and 3, there will be like no number. Okay, so if I ask you the question, okay, so just ask like a question, and that answer will be a discrete random variable. Okay, so suppose if I ask you that how many bank accounts you are having. Okay, so if I ask you the question that how many number of bank accounts. Okay, so I think your answer will be a 3, 4, 5, 6. Okay, so this is what we call a discrete. If I ask you the question that how many members in your family, so again your answer will be 4, 5. Okay, so this is a discrete. Okay, now if I ask you the question that what is your height, so height will be the continuous random variable. Okay, if I ask you about the weight, so weight is again a continuous random variable. Yeah, temperature, as Vikram said, temperature is a continuous random variable. Okay, so you can write over here discrete is nothing but it's a whole number. Okay, so if I ask you like a number of bank accounts, as I said, number of bank accounts, then like total members in your family, and similarly over here height, weight, temperature. Okay, so this is like a discrete and continuous random variable. Okay, I think this is clear to everyone. Okay, means countable. Okay guys, I think this is clear to everyone. Okay, no doubt about between a discrete and continuous. Yeah. Okay, and what is a qualitative variable? Okay, so what do you understand by a qualitative variable? Even this qualitative variable, you can call it as a categorical variable. Okay, so even this is a numerical variable, you can call it as a numerical variable, numerical values, and this is what you can call it as a categorical variable. Okay, now what do you mean by a categorical variable? Anyone can tell me the example of categorical variable? Color liking. Okay, so yeah, which there are different colors. Okay, so suppose if I have a column of colors where we have maybe red, green, blue, violet, so this is your categorical variable. So suppose you have a column of gender where your values will be male or female, so this male and female is a categorical variable. Okay, so very correct. Yeah, so categorical variable means where there is like some category. Okay, so where there is some category. So suppose if I have a column of colors, as Bikram said, okay, so there you can have a different colors. There you don't have any number. Okay, so you can even call it as a class. But yeah, it's like it's like a different categories. Okay, so categories of a red color, categories of a blue color, categories of a green color, and similarly in a gender column, like categories of male, categories of female. Okay, so this is what we call a categorical variable. Yeah, so where there is no numbers, there are like categories, there are like a class, you can say. Okay, so I think now we understand the idea of a data. Okay, so what is a data, and what are like different kind of data. Okay, so what are the different different kind of data. So I think we are able to understand this thing. Now the main now we can try to understand the statistics. Okay, so there are like statistics can broadly categorize or broadly divided into two categories. Okay, so one is called a descriptive statistics, descriptive, and another one is called inferential. Okay, so descriptive and inferential. Now descriptive means what? Okay, so anyone know that what do you understand by a descriptive statistics? Qualitative variable don't have any subdivision. Subdivision means, in what sense you are asking? Subdivision means what? More classification means in color you have red, and then in a red you want like a different classes for red also. That is what you are asking. No, not like a quantitative variable. There is even there is like something that is but we don't need we don't need to do anything with that. I think even there is something I think that is what we call ordinal, and maybe, if I'm not wrong, it is ordinal or something else, nominal. Maybe this is yeah, ordinal and nominal. Yes, Bikram, right? Yeah, nominal and ordinal. So I think ordinal means where we have like our categories in some rank. Okay, so where you have a like category maybe in form of a rank. Okay, so rank 1, rank 2. So in some order. Okay, so where your categories are specifically arranged in like in a specified order. Okay, where you can't like that you can't change. And a nominal means like just with the name, there is no like order like associated with that. So that is what we call a nominal. So yeah, like ordinal. Oh, smoking. How smoking? There are different like even smoking have ordinal. Okay, smoke, don't smoke. Okay. Yeah, so even you can take like this as an example. Although with respect to this, this is like completely fine if you are able to differentiate between categorical and numerical. Okay. Okay, so now come on to the descriptive. So descriptive is just definition of data, while inferential tending to arrive at a decision from data. Okay. Inferential means different people can infer different meaning. You can exactly define something is of descriptive. Okay. Okay, so yeah, descriptive statistics, I think it is very much clear to all of you. It is just an exploration. Okay, so I think someone has written also that this is just an exploration. Okay, so where you are trying to describe your data. Okay, so there are some techniques. Okay, so there are some terms or you can say some techniques through which you are trying to describe your data. Okay, so that is what we call a descriptive statistics. Okay, so there are like two major techniques, you can say. Okay, so a measure of central tendency. So measure of central tendency. Here you have like mean, median, and a mode. And then you have a measure of dispersion. Now here you have a range. And another one is variance or standard deviation. And this is a like these are the whole things which we are going to learn today. Okay, so we are going to cover like all these things today itself. This is like our motto. Let's see. And in case of inferential statistics, okay, so inferential statistics is like something different. Okay, so inferential statistics means what? We are trying to like make some inference. Okay, so we are trying to make some inference, or as people said, like inference means nothing but a prediction, decision, or conclusion. Okay, so we are trying to make some inference on a sample data, and we are trying to and put, or you can say map the same decision, or put the same decision over the population data as well. Okay, so like if someone asks you like nowadays, okay, so I think like this is our election season going on. Okay, so I think election season is going on. So in election season, what people are trying to do, so people are trying to conduct a survey. Okay, so I think all of you guys are aware about the exit polls and all these things, which are like news channels trying to show you, and even people are trying to conduct a survey in different news channel, and different survey companies try to conduct a survey. Okay, so how they are conducting a survey, so they are trying to like take information, they're trying to extract the information or take the information from the sample data, okay, from like a few people, and then they are trying to make an inference, or you can say a prediction for the whole population. Okay, so like if I talk about UP, okay, so UP is a state where like the population of UP is around 24 crore. Now it is not possible for any person, okay, so it is not possible for any person who is like making a survey or like from any background, so it is not possible for him or her to to ask like person by person. Okay, so it is not possible for anyone to ask a person by person and then like try to collect the information from whole like 24 crore people. Okay, it is not possible at all. So now what people are trying to do, so they're trying to collect the information, or they're trying to like conduct a survey on a small sample of a data. Okay, so if state is your population, okay, so now there is like two terms which is necessary one. Okay, there are like two terms, one is a sample and a population. Okay, so what people are trying to do, so they are trying to conduct a survey on a small like a sample of data. Okay, so suppose if I'm talking about a state, so a city can be your sample. Okay, so if state is a population, okay, so now this is your whole population. Okay, so suppose this is like state UP. Okay, now the city can be considered your or a district can be considered your sample. So what people are trying to do, so they're trying to take small samples. Okay, so one sample maybe from here, then another sample maybe from here, then another sample maybe from here, another from here, another from here. So we are trying to they are trying to conduct a survey on a sample data, and then whatever the result they are getting from this sample data, they are trying to put they're trying to like make inference or prediction for the population data as well. Okay, so this is what we call a inferential statistics. Okay, so this small like things is your sample. So the city, you can consider city as your sample, and the whole UP state is your population for this thing. Okay, so this is always a contextual term. Okay, so there is nothing if we are having this much like number of people, so it will be a population, and if we are having this much number of people, so it is a sample. Okay, it is not possible. Okay, so it is always a contextual definition. So in a context of a state, so your city will be like a city can be your sample. Okay, now if I'm talking about a Lok Sabha election, where we are selecting from we are trying to conduct a survey in the entire country, where 135 crore people are there. So in that condition, state can become your like a sample. Okay, and the whole country is like your population. So it's a contextual definition. Okay, it's a contextual definition, right? So now this is what meaning of inferential statistics. So we are trying to conduct a survey, or we are trying to make an inference on a sample data, and then we are trying to map the same inference or the same prediction for the population data as well. So this is what a meaning of inferential statistics. Now even there are tools, there are techniques, there are mathematics through which we can we can prove its credibility. Okay, now we are making a very high claim. Okay, so we are making a kind of a claim that whatever the inference we whatever my prediction for the sample data, this is going to be same for the population data. Okay, so this is a huge claim. Okay, so now there are like different testings are available. Okay, so there are different hypothesis testings are available. Different mathematical equations are available through which we can prove its credibility. Okay, whether the statement is true or whether this statement is false, so we can prove its credibility by using like those mathematics. Okay, so but yeah, I think this is the whole inferential statistics. You need to remember this a sample and population for this. Okay, so yeah guys, anyone having a doubt regarding this inferential statistics? Even at the end of today's session itself, I will give you a like very beautiful book based on this statistics and probability, and I will request you that don't just go through that book, but don't try to don't try to go like a chapter by chapter. Okay, means pages by pages. Okay, because this is a I think it is around 800 pages. Okay, so if you try to go pages by pages, so it will take a very longer time. So just try to learn the main parts. Okay, so even I will show you right now also, and then you can try to read it by yourself, the main things only. One second. So I think the book is now visible to you. Okay, so even the definition for descriptive and inferential is given to you, and even along with the example. Okay, so inferential statistics consists of procedure used to make inference about a population from information contained in the sample. Okay, so I think this definition is easy to understand. The objective of inferential statistics is to make inferences, okay, about the characteristics of a population from the information contained in a sample. Okay, so whatever the information we are getting from the sample, based on that information, we are trying to make inference for the population. Okay, so this is a meaning of inferential statistics. Okay, so even if you want, you can write this definition right now also in your notebook. Okay. Okay guys, now come on to this descriptive statistics. Okay, so a measure of central tendency. And here the very first thing is your arithmetic mean. Okay, so the very first technique is arithmetic mean. Fine. Now this arithmetic mean is again median. What is this? Yeah, mean, median, mode. We are going to cover all the things. First is mean. Okay. So there are like a two way of representation of mean. So one is a population mean, another one is a sample mean. Okay, so suppose this is your data set. So I'm taking one data set, and even I am I open my calculator and I just suggest you and even want you guys to be with your calculator. Okay, although this is very small calculation, I hope. Okay, so suppose this is my data set. Now what is arithmetic mean? So if anyone can like just give a short introduction or one line statement for this arithmetic mean. Average of quantities. Okay, so arithmetic mean is nothing but the average value. Okay, so whatever the data you are having, so average means a mean means nothing but sum of all the data divided by a total number of like values in your data set. Okay, so this is what a meaning of a mean. Okay, so now what is a mean for this this data set? Okay, just try to calculate it and give me the like value. I think this is going to be a 1 plus 2. So 3, then plus 4, then 1, then plus 6, then plus 8, then 10, and then plus 12. So I think in total we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values are there. 5.22. Okay, so I think this is correct. So this is going to be a 5.22. And what is this calculation? What is this value? The summation value is what? Okay, 47. Okay, guys, thank you so much. Okay, and even the value for this sample mean is again going to say same, but the symbol is changed. Okay, so that is why I have written over here. So the answer is again going to be same. So, but a sample mean is represented by X bar. So then this is also equals to 5.2. Fine. So guys, this is my mean. Okay, and why it is called like a mean median mode is why these things are called a central tendency. So these things are called a central tendency because this refers to the measure. This is these are the measures which is used to determine the center of distribution of your data. Okay, so your data is distributed. Okay, so you you can try to even make this graph. You can try to even you are able to see this graph everywhere. This is how maybe your data is distributed. So it can be distributed in any form. Okay, so maybe your data is distributed in this way. Okay, so maybe your data is distributed in this way. Okay. So these are nothing but these are the measures which is used to determine the center of your distribution of your data. Okay, so that is why it is called a central tendency. Okay, now guys, just try to just try to understand the significance of this mean, median, and mode. Okay, this is the that is the most important thing. Okay, so just try to understand the significance of mean, median, and mode. So right now I have just written the I'm just trying to find out the value. Okay, after calculation. Okay, so this is just a simple plain mathematical calculation. And okay, so just try to do the calculation first. Okay, and then if I try to go for the median. Okay, now if my data set is this way, so suppose if this is my data set, maybe 1, 1, 2, 3, 3, 5, 6, 8, 9, and 10. Now, what is the median of this data set, guys? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and maybe 11. Okay, so what is the median of this data set? Can anyone tell me what is a median of this data set? Okay, so 4. So fine. Now, what is the procedure to find out the median? So you need to first need to sort the numbers in ascending order. So you need to sort the numbers in ascending order. Okay, so you need to sort the numbers in ascending orders. Fine. And after sorting the number, you need to find out the middlemost value. Okay, so I think this is already sorted. This is already sorted in ascending order. Okay, and you are having, I think 4 is not the correct answer because 4 is not present over here. And you have like odd numbers over here. Okay, so you have like odd, like total number of values which are present over here is 11. So 1, 1, 2, 3, 3, 5, 6, 8. So this is already sorted. Now try to find out the middlemost value. Okay, so 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So I think the middlemost value is this 5. So I think someone already given the answer 5. So median is 5. Fine. Now if I remove this number, okay, now if I remove like this 11 from here, now then what is the median? If I remove this 11, then what is the median? Median will be one value, na? So it is 4 definitely. Okay, so then you need to find out the average of these two value. Okay, so then you need to find out the average of these two value. So the average of these two value is nothing but 4. So 3 plus 5 divided by 2, and it is going to be 4. Okay, so if you are having an even number of distribution, okay, if you are having odd number of distribution, then middlemost value will be your median. And if you are having an even number of distribution, then you need to find out like two middle values, and then you need to find out the average. Yeah, correct. Fine. So this is a median. So I think every one of you is able to understand the definition of calculation so far. Now the last one is your mode. Now guys, what is mode? Okay, now tell me the mode in this distribution. Yeah, mode will be 2, because so mode is what? Mode is the most frequent value. Most frequent value. So mode will be 2. Okay, so guys, I think till now every one of you is able to understand the meaning. Every one of you is able to understand the calculation. So this, at least till this point, everyone is comfortable. Now just try to understand the significance of all these three measurements. Okay, so just try to understand the significance now. Now just I'm taking one data set over here. Okay, so I'm taking one data set over here. So 1, 2, 3, 4, 5, 6, 7. 8. 9. Okay. So guys, just try to find out the mean of this distribution and a median of this distribution. Okay. So just try to find out the mean and median of this distribution. Quick guys, be with your calculator. Otherwise it will take more time. So what is a mean and what is a median? So median is, I think, quite easy. You need to short this thing first, and then you can easily find out. Mean is 16. So are you sure that mean will be a 16? Okay, now what is the median? Okay, fine, no issue. What is the median? Median is 1. I don't think that median will be 1. Median is 1. Median is in the middle. Just try to short it. So 1, 1, 1. Then you have 2. Then you have 3. Then you have 4. Then you have 5. Then 7. Then 120. So 1, 2, 3, 4. 1, 2, 3, 4. Median is 3, guys. Please. Okay, median is 3. Yeah. Median is 3. Okay, so just try to do one more calculation. So just remove this 120 from here. Okay, and then find out mean and median. Just remove this 120 from here and then find a mean and median. Why are you guys giving me a mode? I didn't ask for a mode, man. Okay, so mean is 2.5 or 5.5. So two different answers are there. 2.5. Okay, so 3 plus 2, 5, 5 plus 3, 8, 8 plus 4, 12, 12 plus 5, 17, 17 plus 7 is 17 plus 7 is 24, and I think total 8 numbers are there. So 24 divided by 3, mean is 3. Oh, guys. So mean is 3 if I remove this 120 from here, and median is 3.5. Yeah, so 1, 2, 3, 4. I think 1, 2, 3, 4. Okay, sorry, 1, 2, 3, and 1, 2, 3. Yeah, so median is 2 plus 2.5. Okay, now guys, just try to just understand that if now what is this value? Okay, what is this value? Okay, so the value which is which is kind of a odd one out, or you can say like a kind of a strange value. Okay, so in this distribution, okay, so for this particular distribution, you can consider this value as a strange variable. Okay, they can consider this a particular distribution, they can consider this variable as a strange value or a strange variable. Okay, so this strange variable is termed as an outlier. This strange variable is termed as an outlier. Okay, so outlier means odd one out. Okay, so which is which looked different from a rest of the values. Okay, so which look very different from rest of the values in a distribution. Okay, so that particular value is termed as an outlier. We term that particular value as an outlier. Okay, so this is an outlier, guys. This is an outlier. Fine. Now, if I introduce an outlier, okay, just try to understand the significance that if I introduce an outlier in this distribution, so your mean, your mean is like varying a lot. Okay, so previously your mean is 3, and after introducing an outlier, your mean becomes 16. Okay, but in case of a median, it is like this value is not vary a lot. Okay, so first the median is 2.5, and even after introducing an outlier, so this value is again like same, it is like 3. Okay, so even if I introduce two outliers, suppose if I introduce like one more outlier, maybe 100, okay, then you can find out that your mean is the difference between the actual mean and the mean after then introducing an outlier is going to be like that difference is going to be like more. Okay, so it may be like a 20, 25 or 26 something. It will it will become a 25 or 26 something. Okay, but this value is not going to this difference is not going to be much. Okay, even after introducing one more outlier, maybe the difference can be like of 2 unit or 3 unit max to max. Okay, not more than that. Okay, so what is the meaning of this thing, that a median works well with outlier? Okay, so in case your data set containing an outlier, so in case your data, if your data set containing an outlier, so in that particular scenario, median works well in comparison to a mode. Mean. Okay, so median works well with outlier. So this is what we can conclude. Okay, so median works well with an outlier. Fine, or even you can say that median is a more more accurate measurement of your data set of your distribution in case your data set containing outlier. Okay, so in case your data set containing outlier, median will be the more accurate measurement in comparison with the mean. Okay, because the value of mean is changed, but even what is our definition? So what is our assumption? So we always assume that suppose if you if like any, so suppose after the examination, okay, so after the examination someone asks you that what is your performance? Okay, so suppose if someone trying to observe your performance in an examination, and you told him that my average marks in an examination is 85%. Okay, so definitely that guy will assume that in every subject your marks will be around that number, around 85. type. Okay, so maybe in one subject your mark will be 80, another one it may be a 90, another one it may be 88, another one it may be 82. So that is what he trying to assume in his mind. If you give him like average of your marks in an examination. Okay, so but if there is an outlier, so the whole distribution is going to be changed. Okay, so that is what the mean is going to be changed at all. Okay, so now at this point of a time, mean is not giving you like a accurate measurement. Okay, the central value. Okay, so it is now not acting as a central tendency of your data set. Okay, so after introducing an outlier, mean is not acting as a central tendency of your data set. Mean is not able to define the central tendency. Okay, but median works well. Okay, so this is what we like a significance of this mean and median. If the outlier present in the middle, what was it cannot, sir. Sorry, sir. How do we identify the outlier? Outlier. How do we, okay, how do you identify the outlier? That I will show you. Okay, that is fine. And yeah, I think if the outlier present in the middle, by this is this is a dummy data set which I have created. Okay, so if you are having an actual data set, so definitely that that value will not be present in the middle, never. Okay, it will be in the like maybe in the last, or maybe in the like at the beginning of the data set, in the actual data set. Okay, so suppose if I am having a data of someone's salary. Okay, so and if there is like maybe some outlier, so it is according to like a kind of an arrangement. Okay, so that will always be present at last, or that will always be present at the starting. So that can be called as a negative outlier. Okay, here it is called as a positive outlier. Okay, so outlier can be on the negative, on the right hand side, or it can be on the left hand side. It cannot be in the middle. Okay, never. Fine. Now try to understand the significance of mode. Okay, so here these two things are important in case you have a numerical data set. Okay, in case you have a numerical data set, so these two terms or these two techniques are very useful. Yeah, definitely. And in a case of median, I think yeah, I think is giving you the I think yeah, he's giving the answer of your query. Okay, so you are shorting the data. Okay, so it won't affect. Oh yeah, thank you very. Now, so if I talk about a mode, now how mode can be useful. Okay, now how what is the like significance of mode. Okay, so suppose in your like data set, if you are having like some missing values. Okay, so in your data set, so not in a numerical, okay, not in a numerical column. Suppose if you are having a like missing value in a categorical column. Okay, so suppose if you are having a data set in this way, and you are having like maybe a gender over here, you are having a salary over here. Okay, or you are having maybe like a different kind of cancers are there. So different kinds of research. Right now I am working on a cervical cancer like a research paper. So there are 3 different kinds of cervical cancer. So a different classes of cancer. So cancers classes I can write. Okay, now so here you may have a like male, female. Okay, so in a salary you must have like some numbers. And in here also you have like maybe a type 1, type 2. Okay, so a type 1, then type 2, then type 3, then again 1, 3, 1. Okay, now suppose in your data set you may have some missing values. Okay, so it is possible that here you have like some missing values. So maybe here you are having like missing values, here you are having like missing values. So in your data set maybe you are having some missing values. Okay, so in case of a numerical data set, so suppose if you are having a missing values in a numerical data set, so what you can try to do, so first you need to identify that whether your data set containing an outlier or not. Okay, so if your data set is not containing an outlier, okay, so just try to understand this thing, and if you want, you can try to write this thing somewhere. Okay, so if your data set, if your numerical column, so this is your numerical column, so definitely salary will be a salary is a like numerical column. So if your numerical column, is having an is not having an outlier. Okay, so try to understand, if the numerical column, if your numerical column is not having an outlier. Okay, so if your numerical column is not having an outlier, then you can try to fill this numerical column with a mean. Okay, so if the numerical column is not having an outlier, so you can try to fill this numerical column with a mean. Okay, second point, if this numerical column is having an outlier, okay, so if this numerical column is having an outlier, then so no outlier. Now, if this numerical column is having an outlier, then you can try to fill the null values, or you can say a missing values, with a median. Okay, with outlier. Okay, now in case of a categorical column, okay, so now you have like two categorical column, one is gender and another one is cancer's class. So now in case of a categorical column, so you can't fill like a categorical column. So suppose if there is a missing values in a categorical column, so you can't fill that missing values with a mean or a with median. So the most appropriate measurement, or the most like specific measurement to fill the categorical column, to fill the missing values in a categorical column, is mode. Okay, so you can try to fill the missing values if there is any. Okay, so if there is any missing value in this categorical column, so you can try to fill this thing with a mode. Okay, so with a mode, like you can call it as a most frequent value, so you can try to fill it with a most frequent value. Okay, so this is what a significance of a mean, median and mode. Okay, so guys, every one of you is able to understand till this point. Okay, anyone is having any doubt till this point? No. Okay, so guys, if you are having a missing value, in a categorical column, okay, so these are like, this is a numerical column, this is a numerical column, and these two is your categorical column, because you are having a categories, you are having male and female, you are having first, second and third. Okay, so if you are having a missing value in a categorical column, then you can fill those missing value with a mode. Okay, so that is where you can use mode, because you can't fill it with a mean and median. Okay, please explain an outlier. Okay, so outlier is like something which is which is like is some value which is kind of like you can say a strange value or odd value in your data set. Okay, so just like in this data set, this value is like kind of an odd value, kind of a strange value. Okay, because every value is like is in the form of ones. Okay, but this value is like 100. Okay, so just you can make any group. Okay, so you can think of any group where there is I think in our childhood we are trying to solve one kind of a problem which is called odd one out. Okay, so that outlier is nothing but you can call it as that odd one out. Okay, that odd value in your distribution. Okay, clear? Okay guys, now anyone having any doubt? No. Okay, thank you. Oh, okay, so someone asked, can we have 5-minute break? Everyone want this 5-minute break? Oh, he himself right? No. Okay. Okay. Okay, guys. Thank you. Okay. So now come on to the measure of dispersion. Okay. So I think we are able to like cover the measure of central tendency. Now just time to talk about a measure of dispersion. Okay. So in measure of dispersion, we have like two things. So one is range. I think range is clear to everyone. Okay, so just give me a quick introduction so that I can move on. Okay, so what do you understand by a range? What do you understand by a range? Great. Okay, simplest. Okay, a very I think this is a correct definition. A difference between a highest value and the lowest value. This is what we call the range. So I think I don't need to take this because this is like a very simple definition, highest value minus lowest value. Now, if I talk about the variance or a standard deviation, okay, so concept wise, both the things are same. Okay, concept wise, both the things are same. Only the formula is like differ a little bit. Okay, now anyone who know the definition or like understand this concept variance or standard deviation, or any one of you like can make me understand that what do you understand by a variance or standard deviation? No. Okay. Yeah, correct. Correct. Deviation. Oh, it's amazing, guys. You guys are genius. Okay, so deviation from the mean value. Okay, so variance or deviation, standard deviation means we are trying to check that how much my values are fluctuating from the mean values. Okay, so we are trying to calculate the fluctuation. Okay, so we are trying to calculate the amount of fluctuation in my data set. Okay, so in a simple term, I can say that we're trying to check the amount of fluctuation in my data set. Okay, so yeah, the correct definition, deviation from the mean value. Okay, how much your value is deviated or how much you are deviated from the mean value. Okay, that is what we call a deviation. That is what we call a variance or fluctuation. Okay, so suppose if I take a simple data set over here, if I take a very simple like data set over here, so that it will be like easy for you to make a calculation. So 1 1 2 3 5 2 4 and maybe 8. Okay, so 1 2 3 4 5 6 7 8. Now if I ask you to find out a mean of this value, okay, so what is the mean of this value, this data set? What is the mean of this data set? 2.7. I don't think it should not be a 13, Sumit, and definitely you are making some mistake somewhere. 3.25, 2.75. Oh guys, you guys are confusing me. I think I need to open my calculator. So this will be a 1 plus 1 2 plus 2 4, 4 plus 3 is 7, 7 plus 5 is 12, 12 plus 2 is 14, 14 plus 4 is 18, 18 plus is 26, 26 divided by 8. So it will be a 3 point and something. So 3.25. Someone give me the answer. Yeah, 3.25. Correct. Okay, no issue. So the mu will be 3.25. Now the variance means what? So the variance or the standard deviation means how much my data set or how much my values are fluctuating or how much I am fluctuating from the mean value. Okay, so this is going to be nothing but summation of x minus mu whole square divided by n. So this is your like variance. Okay, so this is like your variance. Okay, so this is what we call the variance. Okay, or you can say a sigma square. Okay, and if you if you try to find out the square root of this value, so it will be a standard deviation. Okay, so I think okay, I know the shortcut of like calculating this variance, or you can say a standard deviation. Okay, but even if you guys want, I think you can calculate it. I think you are able to understand that how you can put the values over here. So this value is going to be nothing but 1 minus 3.25 whole square, then 1 minus 3.25 again whole square, then 2 minus 3.25, then 3 minus 2.35, then 5 minus 3.25, then a 2 minus 3.25 again, then 4 minus 3.25, and then 8 minus 3.25. Okay, so you need to make like this calculation, and then you are able to find out the variance. And then whatever the variance you are able to find out, you need to find out the square root of that particular value, and that will be your standard deviation. Okay, so even you can use you can go on to the online editor, and from there also you can try to find out. So the standard deviation or the sigma is nothing but it is going to be a summation of x minus mu whole square divided by n. Sir, I need to leave office. If you are going to teach stats only, I am a bit comfortable with it. If you start with Python today, I will stay or I will leave. No, I am not going to start with the Python. So if you are comfortable, so you can leave. Okay. Okay, so guys, let me like calculate this thing for you, or even you can go on to the online like editor and you can calculate this like standard deviation. Okay, or just try to go on to the online editor and give me the value. Okay, so okay, so I think I have an online editor with me. Just okay, can anyone unmute yourself and tell me the values? What are the values I have put over there? Anyone of you? Or else you need to calculate then. 1 second. Okay, 1 second, guys. So 1, 1, 2, 3, 5, 2, 4, 8. I think these are the 8 values over there. Now, if I calculate the standard deviation, so mean is 3.25 and variance is 4.93, and the standard deviation is 2.22. Okay, let me check. No, 3.5. No, I think I can show you the answer also. So this is an online calculator where I have calculated this value. So you can see that mean is 3.25, variance is 4.93. Okay, and the standard deviation is 2.22. Okay, so I will write this value and then we can come on to 4. Let me confirm it. So 4.93. Okay, and then the next value is 2.22. Okay. So 4.93 and 2.22. Okay, So I think we are able to calculate the standard deviation and we are able to calculate the variance. And I think that every one of you is able to understand the significance. Okay. So every one of you is able to understand the significance of this. Every one of you is able to understand the concept of this standard deviation and variance. Okay. Now just try to understand the significance. Okay. Just try to understand the significance, and you are able to get a like very great information from here, a very good information from here, that okay. So now if so there is like one rule, guys. Okay, so even if you try to search on like online, so there is one rule which is called a 68. Okay, and I insist you just go onto the Google and search for a 68 95 99 rule. Okay, and even this is also called as an empirical formula. Okay, so this is also we can also call it as an empirical formula. Okay, so just go on to the Google Chrome and search for this like 68 95 99 rule, or maybe or directly search for empirical formula. Okay, and what this empirical formula suggests, guys. Okay, so what this empirical formula shows you. So this empirical formula tells me that in between a mu plus minus one standard deviation, so in between mu plus minus one standard deviation, we are able to cover 68% of the data. Okay, so we can cover 68% of the data in between a mu plus minus one standard deviation. Second, in between mu plus minus 2 standard deviation, we are able to cover 95% of the data. Okay, and in between mu plus minus 3 standard deviation, we are able to cover 99.7% of the data, which you can call it almost 100% of the data can be covered in between mu plus minus 3 standard deviation. Okay, so mu plus minus 1 standard deviation 68%, mu plus minus 2 standard deviation 95%, and mu plus minus 3 standard deviation 99%. Okay, good. Okay, guys, so this is what empirical formula, or this is what this rule states. Okay, now just try to understand the concept, or just try to understand the significance. Okay, so in a later stage, in maybe tomorrow on or day after tomorrow, we are going to talk about normal distribution. Okay, so there is like a probability distribution function which is called a normal distribution, and the entire data set. Okay, so a 95% of the data set, which is like from this real world scenario. Okay, so from this real world scenario, 95% of the data set is normally distributed. Okay, so remember, guys, that 95% of the data set is normally distributed. Okay, so now what is like meaning of like this normal distribution? So normally distributed, so we talk about like in detail about this normal distribution, but just try to understand. So if this empirical rule states that if my data set is normally distributed, so we are able to cover 68% of the data in mu plus minus one standard deviation. Now our mu is what? Okay, so if you remember, my mu is what? 3.25, and my standard deviation is what? 2.22. And guys, this will not give you the exact information, because this is like kind of a dummy data set which we have created. But then also, if I try to calculate 3.25 plus 2.22, okay, just try to do this, guys. Just try to do 3.25 plus 2.22 and 3.25 minus 2.22, and then give me the range. Okay, just do this calculation and give me the range. 1.03 to 5.47. Okay, so mu plus minus 1 standard deviation. Inside this you are getting 1.03 to 5 point what 5.47. Okay, so I think it is I think my final value or my last value is 8 and my initial value is 1. So yeah, it is able to cover more than 68% of the data. I think we are able to cover more than 68% of the data. Just try to go for a mu plus minus 2 standard deviation, guys. So this can be mu plus minus 1 standard deviation. This can be mu plus minus 2 standard, minus 2 standard deviation, mu minus 3 standard deviation. And this will be mu plus 2 standard deviation and mu plus 3 standard deviation. Okay, just do this mu plus minus 2 standard deviation. Okay, so just try to multiply this 2.22 with a 2. So minus 1.19. So I think even in mu plus minus 2 standard deviation, we are able to cover the complete data set. Okay, so minus 1.19 lesser than or equals to x is lesser than equals to last value is what? 7.69. Okay, so great, guys. So I think here itself we are able to cover the complete data set, and I think the last value is 8. So that we are not able to cover, but we are able to cover 99.7. So almost almost 100% data we are able to cover. Okay, so in left hand side we are able to cover the complete data point, even more than that, and in right hand side also we are able to cover like 99% of the data. And if I take like 3 standard deviations, so it will cover that also. Okay, so if I take like 3 standard deviations, so even 8 is also comes into like inside this. Okay, so I think this point is clear to everyone that so this is so suppose so with the help of mu, so with the help of mean and standard deviation, we are able to get an idea about my data set, that how my data set will look like. Okay, so we are able to get an idea about my data set, that how exactly my data set will look like. Okay, so at least we are able to get the range. Okay, we are able to get an accurate range of my data set with the help of just mu and standard deviation. Now understand one most important thing, guys, that if any value, okay, so if any value, okay, so I think my entire data set, my entire data point is I'm able to cover my entire data set in between mu plus minus 3 standard deviation. Okay, so no matter how long your distribution is, how like bigger your distribution is, you are able to cover the whole distribution, the whole data points in between mu plus minus 3 standard deviation. Okay, now if any data point, okay, now just try to understand that if any data point fall beyond this mu plus minus standard 3 standard deviation, okay, if any data point beyond this value, maybe here, and if any data point fall beyond this value, okay, so if any data point beyond fall beyond this mu plus 3 standard deviation, and if any data point you are able to observe any data point beyond this mu minus 3 standard deviation, so that particular data point is called an outlier. Okay, now I think someone asked me the question that how we are able to identify an outlier. So this is how this calculation will help you to identify an outlier. Okay, now any data point which fall beyond mu plus minus 3 standard deviation, that data point will consider to be an outlier. Okay, and this is how your empirical rule or this like this particular formula helps you. And this as actually this formula, this empirical formula will help you to identify an outlier. Okay, so guys, this thing is clear to everyone. If you are not, just try, if you want, you can write this like this note somewhere. Okay, this is a very important point, that if any data point falls beyond mu plus minus 3 standard deviation, then that data point will consider to be an outlier. Okay, clear to everyone? Okay, and one more thing, guys, that suppose if you're not having a complete distribution of your data, okay, so someone not giving you the information of your like data set that these are all the values which are present in your data set. Okay, so suppose if someone not give you the value, someone not give you the range, but if someone give you just two values, if someone give you just two information, a mean and a standard deviation. Okay, so someone give you just mean and standard deviation, so someone tell you about the mean and standard deviation about your data set. So with the help of only that mean and standard deviation, you are able to get the complete idea, you are able to understand the complete idea of your data set, you are able to plot the complete summary of your data set. Okay, so this is what that is why these two terms, these two techniques is called the sufficient statistics. Okay, so along with so descriptive statistics is fine, even these two terms is also term, so people also call these two terms as a sufficient statistics, because these two terms are sufficient enough to get the complete idea of your data set. Okay, so guys, every one of you are able to understand till this point of till this point. Okay, no one is having a doubt anywhere in a descriptive statistics and along with the significance. Okay, great guys, great. Okay, now just try to okay, so now it's time to understand the inferential statistics, and even I want you to give okay, so just tell me, okay, just for the reference I'm asking, it is not like mandatory that every one of you know, but just for the reference that how many of you are like know the basics of Python, like just the basic. Okay, just the basics of Python programming language. Just give me like your thought. How many of you? No idea, no, yes, okay. Okay, means I think out of 4. Okay, so someone know the basics. Yes, I have some idea. Okay guys, okay, fine. Okay, just do one thing, just do one favor for me. Okay, I don't okay, it's completely fine if you don't know, if you are just a beginner in a Python, it is very much very much clear to me, that is completely fine. But I request you just two things, just try to in tomorrow's session. Okay, maybe we are not going to talk about a Python tomorrow. Even I can talk in I think 30 minutes are still remaining, and I can take a Python also into the consideration for today, because we talk a lot of things about mathematics. But this is my genuine request to you. So just with the whatever the installations needed. Okay, so whatever the installation needed for a Python in your local notebook, sorry, in your local PC. So I want all of you guys to be with that like installation thing. Okay, so be with like Anaconda and be with the Python. Okay, so even I will give you the link at last, but you can try to search for a Python and try to install Python version 3.7, like above 3.7. Okay, so even you can try to download 3.8, 3.9, but above 3.7, and then Anaconda. Okay, so you can search for these two things, Python download and Anaconda download, and you can download like these two things. Okay, then tomorrow or like any other class, if I want to start, so you can try to do the code along with me. Okay, so just try to do this like guys before tomorrow's session. Okay, now okay, so just move on, because we still have like 25 minutes and we can talk about, we can cover a lot of things. Okay, so this is all about a descriptive statistics. Now for the inferential statistics, I think the idea is very much clear, the concept is clear to all of you, but we need to understand the credibility. Okay, we need to understand the credibility, that whatever the statement or whatever the conclusion we are making on a population based on the sample. Okay, so based on this No, if you go on to the Anaconda, you need to install the latest version. So latest version is Python 3.8. So you can install it. Even you can install Python 3.8. It will be more like good, because if both the versions are same, so they're like in a later stage, there is no like kind of problem at a time of running anything. Okay, so you can install Python 3.8, and Anaconda 3.8 is the updated version. Okay, so you need to install the updated version. Right. Now, so just try to understand that like how we are able to get the credibility. Okay, how we are able to credibility of my statement, that whatever the statement or whatever the inference I'm making on a population data set from the idea of a sample, so whether it is like correct or whether it is a wrong. So for that testing thing, we need to like understand the role of probability in stats. Okay, so in a data science, so probability is also very much important, but we need to understand the probability. Uh, we need to understand the like a probability. We need to understand the role. Okay, we need to understand the role of a probability in statistics. Okay, that what is the exact role of a probability in a statistics. Okay, so that is what our idea is. That is our our main understanding is. Okay, so I think most of you guys, if I ask you the definition, if I ask you that what do you understand by a probability, okay, so I think most of you guys are able to answer this question, because the one who is from like a mathematical background, so you are able to answer this question. Okay, but you are not able to like relate this thing, this a probability term with the statistics. Okay, and that is what we need to understand. And even you are able to understand that like even I will try to understand, I will make you understand, but even I will suggest you that even you need to understand this thing from this book also. Okay, so even in this book you are able to in chapter number 4, you can try to go through this 4.1, 4.2, 4.3 figure, and you are able to understand, like even from this paragraph also you are able to understand the role of probability in statistics. And this is what I am going to explain you in a simple language. Okay, so okay guys, so just tell me the definition of a probability. Okay, whatever you know till now, whatever the definition you know, or whatever the like concept you know about the probability, so just tell me that definition. Anyone can give the definition of a probability? Okay, possibility of occurrence, chances of future occurrence, chance of occurrence or happening. Okay. Number of favorable outcome divided by total number. Okay, this is yeah, mathematical definition, calculation. Yeah, correct. Okay, guys. So I think all the definitions are correct, because probability is nothing but a chance of occurrence of any event. Okay, chance of occurrence of any event is called a probability. This is the definition which we have learned in our childhood. Fine. Now just try to understand its role, or just try to now I'm going to relate this thing with the statistics. Okay, so in a statistics we learn one term which is called mode, and mode is nothing but mode is like most frequent value. Okay, so even we can call it as a frequency. Okay, so we can even we can try to get the frequency of any data set, like frequency of any number, and that is also considered to be a mode. Okay, so suppose if I'm trying to like take the shoe size of maybe some of you. Okay, so if I take a like shoe size of like all of you guys, so suppose I'm having like this shoe size. Okay, so 1, 2, 3, so I am having like maybe 7 shoe size over here. Now if I'm trying to find out the frequency of this, all these values. Okay, so a frequency. So 1, 2, 1, 1, 1, 1. Okay, now frequency is not giving me a lot of information. Okay, so suppose if I write like 1, so it is not giving me a lot of information that if there is 1, so out of how many values I am getting 1. Okay, so suppose if someone asks you like your marks in an examination. Okay, so someone asks you that how much marks you obtain in this unit test. Okay, and you are giving the answer that I got maybe a 25. So you got 25. So from like 25. So so you got 25. So you got 20, out of 30 you got 25, or you got like out of 40 you got 25, or out of 50 you got 25. Okay, so like you need to tell the answer in this way. Then only he is able to understand your performance. Then only he is able to understand your performance in in an examination. Okay, so frequency is not giving you a lot of information, but there is one more term which is called a relative frequency. Okay, so a relative frequency. Now relative frequency is what? So relative frequency is nothing but the relative frequency of all these values is going to be 1 upon 7, 2 upon 7, 1 upon 7, 1 upon 7, 1 upon 7, and 1 upon 7. Okay, now if I try to calculate the total relative frequency, okay, so if I try to find out the total relative frequencies, what is the total relative frequency, guys? What is the total relative frequency? So the total relative frequency is going to be nothing but it is going to be 1. Okay, so if you calculate all this value, so the total relative frequency is going to be 1. Yeah, correct. Even the total probability is also equals to 1. Okay, so I think if you guys know, so the total probability is also equals to 1. Now just try to just tell me, guys, that now from this like understanding, can I say that a probability is equals to a relative frequency? Okay, means concept wise, not not in terms of a mathematical calculation, not in terms of a mathematical value. Concept wise, can I say this thing that probability is equals to the relative frequency? Okay, so there is no difference. So can I say this statement that there is no like significant difference between a total probability between a probability and a relative frequency? So can I say this kind of a statement? Okay, and whether this so this statement is correct. Okay, so if this statement is correct, okay, so just try to understand whether this statement is correct or not. Although mathematically the total relative frequency is equal to total probability, but if I try to if I try to understand this like the idea. Okay, now just try to understand the difference between these two terms. Now if I ask you the question, okay, so what is the probability? What is the probability? And I think every one of you is able to answer this question. What is the probability of getting head if I toss a fair coin? Okay, what is the probability, guys? Okay, 1 by 2. I think every one of you, I think, yeah, just stop it. I understand. Every one of you is able to answer this question. 1 upon 2. Fine. Now let's check it. Let's just try to check it. Okay. Just try to do this experiment. Now, suppose if I toss a coin maybe one time and I will get maybe a tail over here. So my relative frequency will be what? 0 upon 1. If I toss a coin maybe for the second time, I will get maybe a tail again. My relative frequency is again 0 upon 1. Third time again I will get tail again 0 upon 2, 0 upon 3. Now fourth time I get head 1 upon 4. Fifth time I again maybe get head, it will be a 2 upon 5. Now I toss like the coin for 10 times, and every time for after this, every time I will get maybe tail. So my value will be 2 upon 10. Okay, now the relative frequency. So just try to observe the relative frequency, guys. Okay, so the relative frequency, it changes Okay, so relative frequency changes. Okay, so it is 0.25, now it is like something, so now it is a 0.2, so the relative frequency changes. Okay, now I ask you the question that what is the probability if I like what is the probability of getting head if I toss a fair coin, and your answer will be a 1/2 every time. But here if I try to find out the relative frequency, so like along with the experiment my relative frequency changes, and this is what a difference between a relative frequency and probability. So guys, what happened, how we are able to get this value, how we are able to get like this value 1/2. So what happened guys, so suppose like someone hypothetically do this experiment maybe for a millions of time. Okay, maybe for 1 crore of time. So some like someone hypothetically like any person try to do this experiment, try to continue this experiment for 1 crore of times. Okay, maybe for 1 crore of time. So after doing this experiment for 1 crore of time, 1 crore times. Okay, okay, so after doing like this experiment for 1 crore times, so definitely he will get like this kind of an answer. Okay, so 49,82,324 maybe. Okay. Okay, and now this value is nothing but 0.4982, which is very much near to 0.5. Now guys, suppose after doing this experiment, after doing like this experiment 1 crore of times, now suppose if someone tried to do this experiment maybe 10 times or maybe 100 times or maybe 200 times. Okay, and there he got maybe the same kind of a result. Okay, so maybe if he try to like do the experiment maybe 10 times, and he will get maybe eight tails and 2 heads, then so whether it, so now is it possible to get any kind of a fluctuation, any kind of a high fluctuation in this value? No, not at all. Okay, so even so after doing like this experiment for 1 crore of times, if we do maybe the experiment 10 times, 20 times, or even 100 times, we are not able to observe much fluctuation over here. Okay, and this is what the exact definition, this is what the actual definition of a probability. Okay, so when we shift our experiment, or when we when we move when we increase the sample size. Okay, so when we increase the size of our experiment, okay, when we increase the like number of experiment, and when we move from the sample to a population. Okay, so as soon as we move towards the population from the sample, now so at that point of time, so it becomes a probability, and the value of probability will be fixed. Okay, and the value of probability will be fixed. Okay, so this is what the exact definition of a probability. So probability is nothing but it is the limiting case of a relative frequency when the sample size reaches to the population. Okay, when the size of sample reaches to the population. Okay, so this is what the definition of a probability. So even if you want, you guys can write down this definition, that probability is the limiting case of a relative frequency when size of the sample reaches to the population. Okay, and this is how like mathematically you can denote this particular thing. Okay, so n tends to infinity, so this is equals to frequency 1. So this is a value of a, this is the formula for a probability of any value x. Okay, this definition is clear to all of you guys? Probability is the limiting case of relative frequency. Probability is the limiting case of relative frequency when size of the sample reaches to the population. Okay, guys. Okay, I think this at this up to this point, everything is clear to all of you. Yeah. Okay. Now, guys, okay, so the last thing for today's session, and then we will continue from a probability distribution from tomorrow's session. Okay, so the last point for today's session is your dependent and independent events. Okay, I think, but I think every one of you understand the difference between a dependent and independent events. Okay, so guys, just quickly give me the difference or the example. With example, just try to understand, make me understand that what do you understand, what is the meaning of for dependent events and what is the meaning of for independent events, or just give me the example. I think that example will be like more than enough. Okay, dependent and independent events. Anyone? Change of dependent event conditional to other event, storm and rain, dependent crop output. Okay, so dependent events. Okay, so just energy is dependent on mass. Okay, fine. So okay, so dependent events. Okay, dependent events are even this is like conditional probability also. So I will explain it. But what is like independent events? So I मैम रुको, मैं क्लास ले रहा हूँ, रुको मैं करता हूँ, मैम क्लास ले रहा हूँ, रुको करता हूँ, रुको मैं भेज रहा हूँ, कर रहा हूँ मैम. Hello. Okay. Change of independent event and conditional. Oh, sorry. Okay, so independent events, example of independent event. So just now, I think we saw the example of independent event. Okay, so tossing a coin is also an example of independent event. Okay, so where, yeah, tossing a coin. So just I think the example which we have discussed, that this is also an example of an independent event. Okay, tossing a coin or throwing a dice. Okay, so these are all the independent event. Okay, where the occurrence of one event is not dependent on the occurrence of another event. Okay, where the occurrence of one event is totally independent, or it is not dependent on the occurrence of any other event. That is what we call the independent event. So like tossing a coin, throwing a dice, or even if I can say like if there is like a storm or maybe a network issue in a Kashmir, so it will not going to put any impact on our class. Okay, because we are far away from that from that place. So both the events are totally independent of each other. Okay. Now, if I talk about a dependent event, so even this independent, so this dependent event can be understand from this like definition of a conditional probability. Okay. So even if you like, I don't know that how many of you know about this conditional probability, but just give me like this answer. I think every one of you is able to answer this question, and with that, our conditional probability and dependent event concept is very clear to all of you. Okay, so suppose like I'm having here we are having a male and female, and here we are having interest rate. Okay, so I think in total 26 students, or maybe 23 students are there in a class. Okay, so 24 students are there in a class, and okay, so I really don't know that how many male and how many female students are there. Okay, but okay, but suppose I'm making this chart, and I'm making this chart like out of this okay, so out of maybe 24 students, maybe 12 males are interested in taking a class, okay, and maybe 4 males are not interested, or 3 males are not interested in taking a class, okay. Now 9 are remaining, so out of 9, maybe 7 are interested in taking a class and 2 are not interested in taking a class, okay. So this is my like a table which I have prepared from 24 students, okay. Now if I ask you the question, okay, now if I ask you the question that what is the probability, what is the probability, what is the probability that if I select one female at random, then that female is interested in taking the class. Okay. I think this question is clear to everyone, and even I make like underline. Yes. Okay, 1 second. One female at random. Okay, you need to focus on this particular word. Okay, so what is the probability that if I select one female at random, then that female is interested in taking a class? Okay, so 7 upon 9, 7 upon 9, 1 upon 9, 1 upon 9. Okay, so okay, so someone give the answer as 7 upon 9, someone give the answer as like 1 upon 9. Fine. Okay, 2 is 7 upon 9, 3 is 1 upon 9. Fine. Okay, now okay guys, so anyone can tell me that how this a 7 upon 9, how the answer is 7 upon 9? Can any one of you can explain this answer? Or how like anyone can explain this like 1 upon 9? Okay, don't make a guess. If you know the answer, if you understand, then try to explain it. Female or interested, total female out of 9 female. So you need to select one female, and so you need to select one female at random. Okay, so if it is written that it is a condition that suppose if I select one female at random, then what is the probability that that female is interested in taking a class? What is the probability of this? I'm asking. Okay, so 7 upon 9 is the correct answer, but just try to understand that how this 7 upon 9 comes. Okay, so first try to like plot this thing. Just try to plot like whatever the question I have asked to you. Just try to plot like this question in. Okay, so just try to like plot this question in like in a mathematics. Okay, so just try to give the shape. Just try to give the shape of mathematics to like this question. So I'm asking you that what is the probability that I'm asking you the probability of an interested candidate, okay, interested students, and given that that student will be a female, okay. So I'm asking you the probability of interested student, okay, given that, okay, it is already given that the student should be a female, fine. Now, this is how I can denote this thing that probability. So now I need to find out the intersection. Okay, so the student must be interested also. So the student must be interested also. It means what? It means what? So try to like understand with this thing. So I ask you that I want a probability of an interested student. Okay, I want a probability of an interested student. So this is what I want. and that student should be a female only. That should be from female. Okay, so this kind of a box I can prepare. Okay, now just try to get the intersection. Okay, so where this like this box is intersect, so I think this intersect at this point. Okay, 7. Fine. So sorry, so that intersection value is 7 and total number of females are 9. So this is my final answer, 7/9. Okay guys, fine. So this is what we call a conditional probability. So conditional probability is what? Conditional probability is nothing. Conditional probability is defined as the probability of occurrence of one event given that another event has already occurred. Okay, so this is what the definition of a conditional probability. Okay, so probability of occurrence of one event given that another event has already occurred. Fine. Okay guys. So it sounds like some so is going on. Okay, conditional. Okay, so conditional. So from where you want this once more? You want me to repeat this definition of conditional probability? Okay, so conditional probability is nothing but okay, so the probability of occurrence of one event, the probability of occurrence of one event given that another event has already occurred. Okay, so this is the definition of a conditional probability. Fine. Okay guys. Okay guys, so okay guys, so I think this is it for today's session, and just try to do like the things which I have asked to you. Okay, so even I will like share the link with you. Okay, so just like 1 minute, I will share the link with you. So this is a link for to download the Python, and the second link I am given to you, and this is a link for download the Anaconda. Okay. Okay, so these are the like 2 links, and along with that guys, remember that in tomorrow's session, so come with this like definition. Okay, so probability distribution. Okay, so just try to read it from, just try to like get something about this thing from your side, so it will be like much interactive session and you will enjoy the session more. Okay, so probability distribution and with the Python installation. Okay guys, so sir, I want to change the job to IT sector. Okay, I'm not in your WhatsApp group. Okay, book PDF, yeah, I will surely give it to you. So I want to change the job to IT sector. How much this session will be helpful? So this session, Sumit, this session is very like a basic session. So this session will be helpful to like to start your like your journey Okay, you can start, and that is why we designed this session. Actually, we are taking a session where we are trying to cover the complete thing, but here we are trying to take a basic, so it will give you the kind of a booster, and it will like give you the idea that what are the things you can try to learn. Okay, so even if you continue this thing, so definitely at one stage after maybe, and if you continue this journey, so after after like 3 or 4 months, you can definitely apply for a data scientist job. Okay, and data scientist is the I think highly paid job in the entire IT industry. Okay, so maybe if you want like pure data scientist job, so it will take maybe 6 months to you. But even if you continue this learning for 3 to 4 months continuously, okay, with the focus and determination, so we will get at least you will start getting the recommendation in this sector. Okay, so it will help you a lot. Okay, it will give you the beginning, because these are the basic things. These are the this is, you can say, like a backbone. Whatever we are trying to learn this time, this termed as a backbone of the machine learning. Okay, so this mathematics is very much important. Yeah, this even the significance which I have told you. Okay, the outlier, the significance of an outlier, all this significance is will help you, and even I will give you the significance of the data set. So these words, this a data set and the outlier, these words are mainly used when you solve when you're trying to solve the problem of artificial intelligence. Okay, you can do in a pie chart. It is totally depend on you, but I recommend Jupyter Notebook. Okay, as a beginner, for a beginner, I recommend Jupyter Notebook. So this is my recommendation. You can go with the PyCharm, you can go with the VS Code. Okay, guys. So yeah, thank you so much for your attention, and we will meet tomorrow at the same time.
Okay, sir. Thank you, sir.
Thanks, sir. Thank you.
Thanks a lot.
Thank you, sir.
Thank you, sir.
Thank you so much.